Hello again to you all. This is the second podcast of your very first week of whatever this is called. I don't know. Doing our at-home learning. Anyway, I forgot to show you this page, the last one. You should have, at the end of what we did, complete number 1 in the weekly assignment number 1. Hopefully that was clear from the email sent to you on Tuesday. Moving on, guys, this is section 2A. So we're now focused on the next objective on the list, which is going through something called converting degrees Celsius, which is super familiar, nothing strange about that, right? To what is called the Kelvin scale. Now, a few of you might be familiar with Kelvin scale, but for some of you, it's going to be pretty new. This whole degrees Celsius and Kelvin scale is all about temperature, of course. Now, here's the deal. If we are talking about gases, with lo and behold, this entire unit is gases, then no exception, absolutely all the time, you must use Kelvin scale, which means it is impossible for you to do calculations to deal with gases unless you know how to convert to Kelvin scale. That's our first focus today. Now, ultimately, just a little bit of background of where this thing comes from. There's something that is called absolute zero. And absolute zero is this theoretical, essentially an idea where molecules are so stinking cold that they stop moving. And if they stop moving, then how is there going to be space between them? If there's no space between them, theoretically, they don't really have a volume anymore. Now, hence, this is that whole idea of it's a theoretical thing. If we were in class, we'd talk a whole lot more about absolute zero. But at this point, what I want you to recognize is absolute zero happens at the incredibly cold temperature of negative 273.15 degrees Celsius. That, folks, is incredibly cold. Now, if you check out the bottom of this slide here, there's a little note that says, hey, negative 273.15 degrees Celsius is equal to 0 Kelvin. All right, so what that means is we've got a little cheat basically to help you convert from one to the other. If you were to go from degrees Celsius to Kelvin, all that means is we have to add 273.15, and that'll take us to kelvins. That works pretty good. The opposite, of course, is true as well, and sometimes this comes in handy. If you were to go from Kelvin back to degrees Celsius, you're not going to add that amount, you're going to subtract the exact same, so minus 273.15. And we'll play around with that quite a bit more. All right, here we go. So just a little bit of a side note here, guys. You don't have to memorize anything that's on here. I just think it's kind of interesting. There's a few different scales that are here. Fahrenheit scale, our folks and friends down in the States use that. It's kind of a, in my opinion, useless scale, no offense. Okay, Kelvin scale, fantastic scale. And good old Celsius, that's familiar with us. Rankine scale, I don't know where that one's from, but it's another comparison that you can check out. But look at this, right? Kelvin scale at 0 is Celsius negative 273.15. Compare an implication of this, though. If we go all the way up to 0 degrees Celsius, well, that means that we add an extra 273.15 to the Kelvin scale to get to the exact same equivalent, right? These are lined up on purpose. So these go together. 0 degrees Celsius is identical to 273.15 Kelvin. I mean, there's more, right? Look, if you go to 25 degrees Celsius, that's 298.15 Kelvin. In other words, 25 plus 273.15. Hey, there we go, 298.15. Like I said, you'll get some practice on this. So let's play. If you look at these numbers in terms of where they actually come from, remember, when you go from degrees Celsius to Kelvin, that process is adding. And what do you add? 273.15. Okay? So if we take a different number other than 0, something so easy, like 25, degrees Celsius, same thing. Take that 25, nothing else changes, plus 273.15, and that's where we get that 298.15. If we wanted to go the other way, like let's say we're going from an original number of 373.15 Kelvin, and I say, okay, convert it to degrees Celsius, then we do the opposite, minus 273.15, okay? Please take note of this. You're going to have to do some questions very similar to this in your homework assignment. All right, let's try a couple. So you have in your regular notes, if you're following along, blanks where this is on yours. So make sure you're going through it. So essentially what we're going to do is take our original value here of 15 degrees Celsius. And when you're converting from degrees Celsius to Kelvin, you need to take that and add the 273.15. When you do that, you're going to end up with, and use your calculators, follow along with it, right? Otherwise, there's no point actually sitting here and not doing it with me. Follow it, right? Go through the process. We get 288.15. Units are important. Nothing's changed. Kelvin. We're going to talk about sig digs in a moment, so just hold off on those. Okay. Look at the next one. This one's going a different direction. This time we're going from Kelvin to degrees Celsius. So it doesn't make sense to add the 273.15. This is that circumstance where you're going to have to subtract it. We're doing the opposite, right? Opposites are logical. So 287.65 Kelvin, and this time subtract 273.15. And in the end, take out your calculators, do some number crunching, please. 14.5 degrees Celsius. I'm doing my best writing on this thing, guys. My leftiness is a little interesting, so here's hoping it keeps working. Okay, let's talk sig digs. Here's the deal. The reason why I wasn't careful to put my end answer for either one into significant digits is honestly, usually when you do this, you're going to use these numbers again, right? This isn't the last time. We're doing this for a reason so that we can number crunch with this thing later, and we can number crunch with this thing later. So after you've number crunched, this is what we're focused on in terms of sig digs. There'd be two of them, right? Or after we number crunched, this is what we'd be focused on for sig digs. In that case, there'd be 5. So keep that in mind. The number crunching comes later. Hopefully that's feeling okay. If not, lucky you, you can listen to me again. We are doing one more. Actually, you know what? No, we will. Let's finish that section. Sorry. This is 2B. So this is also related to number crunching and figuring out conditions. This is about standard conditions. And guys, this is a pretty short one. Ultimately, when it comes to chemistry, we try to standardize the conditions that we do different sorts of labs in. Because if we don't, data that one person does in Canada versus someone else does in China, someone else in Australia, they'll all be different. So we have to have things consistent. One of the ones that we use is called STP. And make sure you write this in, that it's that standard, there's the S, temperature, there's the T, and pressure, there's the P. Now, the good news is you don't have to memorize these. I'll show you where to find them in a second. But this is at 0 degrees Celsius and at 101.325 kilopascals. Take note of this thing. This kilopascals might be new to some of you. Kilopascals is a unit, and it's the unit we'll use the most for pressure. And in terms of what it stands for, write it down. So kPa equals kilo. I ran out of room on that side, so I'll split up the word Pascal. Okay? Now, ultimately, this is when water freezes. And it would be really, really uncomfortable to sit there and do a lab at freezing for, honest to goodness, hours and hours on end. That's how research works. It's not a short thing and then you're done. So we have another scenario then, which was designed, in all honesty, so people in the lab could be more comfortable and not sit there freezing, trying to get some decent data. And this is called, notice the front letters again, S for standard, A for ambient, T for temperature, and P for pressure. SATP. Ambient literally means more comfortable, okay? Take note of these. You, again, do not memorize them, but you'll have to know where to find them. Okay, 25 degrees Celsius, but ding, ding, ding. Are we really concerned with Celsius? No, we're concerned with Kelvin. So that's the key number there. All right. The good news is, don't memorize. They are on your data sheet. This is a little clip of your data sheet right here. It's kind of just one that I blew up, and here it is. So guys, hopefully you have your data sheets. If you don't, I've uploaded them onto this new Google Classroom so you can access them on there, no problem. Print them if you want, or just use them online, whatever works best for you. I know there's a couple things there about molar volume. Yeah, we're not going to use that anymore because you just don't got time. So be it. There's another really useful thing there, though, that I'll call your attention to. There's kind of a little cheat in terms of how to do your degrees Celsius to Kelvin conversion. So that's pretty nice, right? If you forget that number, 273.15. All right, last bit. Today I remembered this is your homework, please, to go with this podcast. On that weekly assignment, you should complete number 2, 3, and 4. And you have the capability now to do so. Adios for now, folks. Have a good one.